Hello, welcome back. We have discussed about confidentiality property. And in this lesson, we're going to discuss about integrity property. What are the techniques that we can use to achieve the integrity property of the message in transit? So the challenge here that we are trying to address can be formulated as, how does Bob recognize tampering with data sent from server? So assume that Bob wants to retrieve some kind of information from a website or from a database or from some kind of information stored in some kind of server. The data will have been transmitted through the internet, which is also known as a public channel. It means that if the attacker wants to kind of modify the message here along the way, they might have done it. So the challenge that we're trying to deal with here is, if there is such a case, is there a way for Bob to recognize there has been tampering with the data? And that is an issue that we are going to deal with we're going to deal with. So let us go back to our running example again, Alice and Bob. Alice is sender, Bob is a receiver. Alice wants to send a message, please transfer $1 million to account A. And Mallory is a bad guy. He wants to modify the message into something else. Instead of account A, he say account B, which could have been his own account. And such an attack is known as the threat to message integrity, because the message that Bob will receive will not be the original message anymore if Mallory has modified. And such an attack is known to be difficult to prevent. And at this point in time, at this point here, you should be thinking yourself why it is difficult to prevent. Unfortunately, in this course, we are not trying to deal with this scenario. Instead, the techniques that we are going to use is about detecting if there is such an attack. If there is an attack, can we use some kind of technique to detect? So message integrity technique can be used to detect such an attack. And in this slide, I will give you the concept behind the message integrity attack before diving into the actual techniques that is being used to detect the message integrity. So the concept here is, here we go. Alice sent a message M, and we use a kind of a function, let us denote as H, to compute a small piece of information as a proof of message integrity. Let me denote it as H, which basically map the H function, basically map the message M to a small piece of information. And then Alice will send both M and H together to Bob, the receiver. So when Bob receives the message M, he will use the same function H to compute the message integrity proof value. Let me denote it as H prime. And then next, he will just compare the H value that he also received together with M, and then check if they are equal. Of course, if the message has not been modified with, the same message M will map to the same hash value, the same H value, and then they will be equal. And there is a way for Bob to know that the message has not been modified with. So let us consider a different scenario where Mallory go and modify the original message into M prime along this public channel. Again, same here, when Bob receives the message, he will use the same function H to compute, which will result in the small piece of information again, H prime, and then he will compare with the H that he received. Since the message are not the same, M prime will not map to the same H value. In that case, Bob will detect that the H value are not the same, and then he will know for sure that the message has been modified with. So that is the concept behind message integrity technique. And before we dive into the actual technique itself, there are two kinds of questions that we need to address. So how is this message integrity proof computed, and how can we send such message integrity proof over a public channel? So essentially, there are two types of technique that can address that problem, that can address this challenge. And these techniques are known as symmetric proof, asymmetric proof, just like what we have in when we are talking about encryption, where we had symmetric encryption and asymmetric encryption. Similarly, here we have symmetric proof and asymmetric proof. And in terms of symmetric proof, we will discuss about message authentication code. There are many different implementations that implement symmetric proof method. Among them, we will only be discussing about message authentication codes, also known as, in short, MAC. And in terms of symmetric proof methods, we will discuss about digital signature. Both MAC and digital signature are constructed based on hash function. And therefore, before we can discuss about these two techniques, we have to first deal with hash function. So in the next lesson, we'll be discussing about hash function. That's it for now. Thank you for attention. See you next time.